This is Geometry Unit 9, Lesson 7 on special angles and cofunctions. What we're going to look at in this lesson are some trig ratios that we run into for some special kinds of right triangles. So we're going to investigate those. The first one we're going to do is draw an isosceles right triangle with legs that measure 1 unit. So I'm going to draw myself an isosceles right triangle. First I'll make a solid line. If it's isosceles, that means that two sides, the two legs, are congruent. Like so. So that means this leg and this leg are congruent. Here's my right angle. And the legs are going to measure 1. This is 1 and this is 1. Now, if this is an isosceles right triangle, what do we know about the other two acute angles? Well, they should be congruent. The base angles would be congruent. Now, what else do we know about these two angles? They have to add up to 90 degrees. So if they have to add up to 90 degrees and be congruent, that means that this angle's 45 and this angle's 45, because this one is 90. So the measures of the acute angles will be 45 degrees. So this is a 45-45 right triangle. 45-45-90 sometimes it's called. All right, now, what is the length of the hypotenuse? Well, the hypotenuse would be right here. And how do you find the length of the hypotenuse? Well, why don't we just use the Fabian Theorem? Leg squared plus leg squared equals hypotenuse squared. It says leaving radical form. So 1 squared plus 1 squared is equal to h squared. So that's 1 plus 1 is h squared. 2 is equal to h squared. So that means that h is equal to the square root of 2. So that means this is the square root of 2. Okay, so now using this triangle, not your calculator, find the exact values in fraction form of the following. Sine of 45. Well, we can use either of these angles. I'm going to use this one right here. Opposite over hypotenuse. Remember, it's SOHCAHTOA. Opposite over hypotenuse would be 1 over the square root of 2. The cosine of 45. Use either angle, doesn't matter. Cosine of 45 will also be 1 over the square root of 2 because it's adjacent over hypotenuse. 1 over the square root of 2. And the tangent of 45, if I take this angle or this angle, doesn't matter, opposite over adjacent. Opposite over adjacent would be 1 over 1, which is equal to 1. So the values of sine and cosine of 45 are the same, and the tangent of 45 is 1. So always, when you have a 45-degree angle, it always will be 1 over the square root of 2, 1 over the square root of 2, and 1. So that will give us a pattern later on that we'll talk about. Now, for the next special kind of triangle, we're going to start with an equilateral triangle. Remember, equilateral means all the sides are the same. So all three sides are congruent. Okay, so these three sides are now congruent. And let each side measure 2. So this side's 2, this side is 2, and this side is 2. Now, we're going to draw an altitude in this triangle. So I'm going to do the dotted line so you can tell what I did. There's my altitude right there. Remember, altitudes are perpendicular when you draw it in. We now have two congruent triangles. So it says erase one, but let's just focus on one of them. So we're just going to focus on this one right here. We're going to focus on that one. Because these two are identical, so whatever I do to this one, I'm going to do to this one. Now, those two triangles are congruent. Now we want to find the measures of the acute angles. Now, if this is an equilateral triangle, what would be the measure of each of the angles? Well, there's 3 angles, and they're all congruent, so that each one would have to be 60 degrees. So this angle would be 60 degrees. Technically, so would this one, and up here, this would be 60. But what does the altitude do to the angle up here if this is an equilateral triangle? Well, it bisects it. This side and this side are congruent, so that means if this whole thing is 60, these two would be 30. So that creates what's called a 30, 60, 90 right triangle. Now, of this pink triangle right here, let's find the length of the two legs. All right, well, the shorter leg is easy. If I look at this leg right here, the altitude comes down. What does it do to the base? It bisects the base. So if this whole thing is 2, that means that this right here is congruent to this. They would both be 1. So the shorter leg is going to be 1. Now the longer leg, it says leave the longer leg in radical form. Well, if we want to look for the longer leg here, on this value right here, the longer leg is actually the altitude. So if we want to figure out what that value is, I'll call it A so we know it's the altitude. Leg squared plus leg squared equals hypotenuse squared. A squared plus 1 squared equals 2 squared. So A squared plus 1 equals 4. A squared is equal to 3. So A is equal to the square root of 3. So this value right here is the square root of 3. Okay, so using the triangle, not your calculator, find the exact values in fraction forms of the following. The sine of 30. All right, remember SOHCAHTOA. All right, so we go from the 30-degree angle, opposite over hypotenuse. Here's the 30, opposite is 1, hypotenuse is 2. So this is going to be 1/2. All right, what is the cosine of 30? The cosine of 30, start from 30, is adjacent over hypotenuse. So which side is adjacent to this? Would be the square root of 3 over the hypotenuse, which is 2. The tangent of 30, opposite over adjacent. So starting from 30, opposite would be 1, adjacent would be the square root of 3. 1 over the square root of 3. Okay, now let's do the same thing for the 60-degree angle. Sine of 60, opposite over hypotenuse. Opposite is the square root of 3. The hypotenuse is 2. The cosine of 60, adjacent is 1, hypotenuse is 2. And the tangent of 60 is opposite over adjacent is the square root of 3 over 1, which is just the square root of 3. Okay, now you may notice some values repeat here. We'll be talking about that in just a minute. So there are specific values when we have a 45, 45, 90 right triangle and a 30, 60, 90 right triangle to quickly find the legs and hypotenuse if we only know one of them, or you can memorize these 9 special trig values. These values here and for the 45, 45, 90 will lead to a pattern. Let's take a look at what the pattern says. Okay. If we look at, in general, the 45, 45, 90 right triangle, what we end up with is, on here, the legs are equal. Here and here are the same. Whatever this value happens to be, the hypotenuse will be the leg times the square root of 2. Okay? So, for example, if this side is 9, this would be 9. This side would be 9 times the square root of 2, if you know this pattern. In a 45, 45 right triangle, if the legs are equal, with the legs equal, the hypotenuse is the leg times the square root of 2. Now, again, you can always use the Pythagorean theorem and figure that out, but if you know this pattern, it works really well. So, in general, 45, 45, 90, the legs are equal, the hypotenuse is the leg times the square root of 2. Now, the 30, 60, 90 right triangle had a different pattern. We have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Okay? And let's look at our values here. If we look at the value A right here, this is the side opposite 30-degree angle. Here's the 30-degree angle, the side opposite it. This is equal to half the hypotenuse. Okay, so whatever this is, the 30-degree angle will be half that. And the hypotenuse is double the shorter leg. So whatever this is, double it and you have the hypotenuse. And for the side opposite the 60-degree angle, it is the shorter leg, or half the hypotenuse times the square root of 3, or the shorter leg times the square root of 3, or half the hypotenuse times the square root of 3. All right, so if you know that pattern, you can find these values quickly. So for example, say that this leg was 10, or the hypotenuse was 10. That means the A would have to be 5. And then this side would be 5 times the square root of 3. So without having to use the Pythagorean theorem, if I know this pattern, it makes it pretty easy. All right, so the side opposite the 30-degree angle is half the hypotenuse. The hypotenuse is double the shorter leg. And the side opposite the 60-degree angle is half the hypotenuse times the square root of 3. All right, so let's see if we can apply this in some problems. All right, so I copied my triangles up here at the top so we have something to refer to. In the diagram, DB is equal to 4, which is the side right here. BDC is 60 degrees, which is this angle right here, 60 degrees. And then AC and BC are congruent. So here's AC is congruent to BC. Okay, now, since I have those values, and from here, I want to find, first of all, the measure of angle DBC. All right, so DBC is this angle right here. Well, if this is a right triangle and this is 60 degrees, this is 90, that makes DBC equal to 30 degrees, because this has to add up to 180 degrees. So DBC is 30 degrees. All right, the measure of angle A. Angle A is right here. Okay, now, remember that AC and BC are congruent, making this an isosceles right triangle. So if AC and BC are congruent, that means A and the whole angle B here would have to be how many degrees? Well, each one would have to be 45, because it's isosceles. So the measure of angle A is 45. Now that also means that this whole angle right here is 45 degrees. So what does that make the measure of angle DBA? What's the measure of this angle right here? Well, if the whole thing is 45 and this part of it's 30, that leaves 45 minus 30 is 15. So angle DBA is 15 degrees. All right, now I have my values for my angles. So now I know I have two triangles, a 30, 60, 90 right triangle, and I actually have a 45, 45 right triangle. Look at the whole thing. So knowing that, let's look at DC. DC is part of this triangle, and DC is across from the 30-degree angle. Okay, so if we go back up here, here's the 30-degree angle, here's A, and it's equal to half the hypotenuse. Well, on this triangle, the hypotenuse is DB. So DC is half the hypotenuse, because it's opposite the 30-degree angle. So that means that it's going to be 1/2 of 4, so DC is going to equal 2. So this value right here is 2. Okay, now let's see if we can do some more. The next thing that we want to find is going to be CB. So if I flip back to my picture here, CB is this side right here. Now remember that if this is a part of the right triangle, this side is opposite the 60-degree angle. So the pattern opposite the 60-degree angle is whatever the shorter leg is times the square root of 3. So if this is 2, that means that this is going to be 2 times the square root of 3. Because this is going to be opposite the 60-degree angle, it's going to be the shorter leg times the square root of 3. Which means it's going to be 2 times the square root of 3. And for this right here, if this is 2 times the square root of 3, that means that this is isosceles. This is also 2 times the square root of 3. So AC is equal to BC because of isosceles, so it's equal to 2 times the square root of 3. All right, and then AB. Well, AB, if we look at this triangle right here, is the hypotenuse. Well, if this is a 45-45 right triangle, if we use this pattern right here, remember the pattern is the hypotenuse is whatever the leg is times the square root of 2. So if it's the leg times the square root of 2 for AB times the square root of 2, we found the leg previously up here, 2 times the square root of 3 times the square root of 2, multiply these together, you get 2 times the square root of 6. 3 times 2 under the radical, you can multiply. So AB is 2 times the square root of 6. And the last thing is to find AD. Well, AD would be this piece right here, so it would actually be 2 times the square root of 3 minus 2. And that's as far as we can go to get the value. All right.